welcome to the next session. Before we start, I want to make a few announcements. Don't forget to rate the presentation on sketch.com afterwards. Since this is the last session before lunch, don't forget that lunch will also be served on these upper levels here, behind the showcase and on the terrace, not only downstairs. And the third thing is please check the room changes due to the power outage. And with that, I think we're ready to for the presentation by Shilla Saebi and Joshulyne Park. Shilla is working at Comcast and Joshulyne at NBC Universal. And we will hear a presentation, Don't Catch Feelings, Catch Issues with Kuberhealthy. Welcome, Shilla and Joshulyne.
Thank you, Federico. Welcome, everyone. Thank you for coming to our talk, Don't Catch Feelings, Catch Issues with Kuberhealthy. And since we recently developed the new version of Kuberhealthy 2.0, we decided that this title might be more relevant. So Kuberhealthy, an operator for synthetic monitoring on Kubernetes. My name is Shilla Saebi, and this is
Joshulyne Park.
And we both work at Comcast. I work as an open source program manager.
So I'm a software engineer, actually not at NBC, but at Comcast Technology Solutions.
All right, so I'll quickly go over the agenda. This talk is you're mostly going to be hearing from Josh. I'm going to give you a little bit of information on the Open Source Program Office at Comcast and what we're even doing here at this conference. Also, Josh will be telling you a story, and we will talk about Kuberhealthy 2.0, which was recently released, and then we'll do a live demo, and then how to contribute to Kuberhealthy. So let's talk about our open source journey. I won't go through every single one of these points, but 2006 is a date that we know that we were doing open source here at Comcast. I went around with my colleagues and talked to figure out who's been doing open source, what's the latest date that we can get back to, and 2006 was the date that we found was the most common, and we know that at that point we were consumers of open source. 2012, we launched our first open source projects on github.com/Comcast. And then fast forward to 2013, the Open Source Advisory Council was formed. This is a group that consists of folks from our legal team as well as some engineers across different organizations at Comcast and the Open Source Program Office. This group decides ultimately what becomes open source and what doesn't. And I will say that the acceptance rate is 99% in the last 2 years. So, and that's how our team is related to the Kuberhealthy team and other engineers across Comcast. They come to us and say, hey, we want to open source this cool thing. We say most of the time, yes, and Kuberhealthy was one of those. And they came in around 2018 is when Kuberhealthy was open sourced. So back over to 2019, you'll see that we have several open source projects now. We're showing up to these events. We're sharing our story. We're also open sourcing things. We have more strategy around our open source. We also did 2 events last year. We did one in Denver and one in Philadelphia, open source events that were open to the public, so open source conferences, if you will. And a little bit more about the Open Source Program Office, which is the team that I work on. I started at Comcast back in 2010. I was an operations engineer on the Exchange team. Back in 2015, I got my hands into open source. So I'm actually pretty fresh to the open source community as well. I started contributing back, fell in love with the open source community, and then I started working on the Open Source Program Office, which opens its doors in 2017. You'll start seeing that a lot of companies, they have open source program offices. We're part of a group called the To-Do Group, which is talk openly, do openly, with other OSPOs that are there. It's pretty cool. Our team supports over 9,000 technologists. We have over 200 repos on GitHub. We're a 6-person team. Most of us are program managers, and we also have a software engineer on our team that helps us with our tooling, automation, et cetera. And if you want to find out more on what other projects we're doing with open source, you can always visit comcast.github.io. And now I'm going to pass the mic over back to Josh, and she will talk to you about Kuberhealthy. Back to you, Josh.
All right. Hi, everyone. Thank you, Sheila, for that great introduction in Comcast journey in open source. So like I mentioned before, my name is Joshulyne Park. People call me Josh, and I'm a software engineer on the Kubernetes team at Comcast Technology Solutions. Comcast Technology Solutions is a B2B organization that provides tools, software, and platforms for other video streaming companies. We're an office located in Seattle, and there's a few of us here as well. So now I'm going to get to the Kuberhealthy side of the talk, and I'm hoping that during my portion of the talk that I can accomplish two things. First is to inform you guys more about what Kuberhealthy is as a project and a lot of the development and work we've been doing over the past few months. And second, hopefully get some of you guys who are Kubernetes operators or developers interested in implementing Kuberhealthy in your own Kubernetes clusters or possibly contributing to our open source project. So story time. I'm going to share you guys a little story about Kuberhealthy. And our story begins with two characters. We have our kube operator, Jake, and we have our application developer, Kim. Two very common characters in our industry today. And some of you here might relate with one or the other more. So Jake, our kube operator, is a huge fan of Kubernetes. I mean, it's the latest and greatest. It's the shiniest new toy out there. And he's super excited to get a bunch of the application developers in his organization to adopt Kubernetes and start using it to ship and basically ship their products and services onto Kubernetes. Our app dev, however, Kim, is a little skeptical about Kubernetes. I mean, she's completely new to the technology, not familiar with it at all, and honestly, she's just wondering, like, if I deploy my services and products onto it, how can I make sure it's not going to crash, burn, and die? So Jake, our kube operator, in order to reassure our app dev, Kim, decides to add standard monitors, looking particularly at node health and applying standard metrics just to ensure cluster functionality. Kim is somewhat reassured and says, all right, let's go for it. Kubernetes is the latest and greatest, and she decides to ship her services and products onto Kubernetes. Some time passes, and more app devs in Jake's organization start realizing the benefits of Kubernetes very quickly, and more people start adopting it. I mean, despite the steep learning curve that a lot of app devs are facing, they're quickly realizing the benefits Kubernetes is providing. I mean, none of us would be here if it wasn't the case. So everything's good so far. However, one day, Kim comes back to us and says, my pod is not working. It's stuck in container creating. What's going on? So Jake decides to take a look at this and first wonders, is it a misconfiguration error? Did they put a wrong spec? Is there something wrong with it? And because usually that's the case, right? When an app dev comes to a kube operator saying my pod isn't working, it's usually some sort of misconfiguration error. However, Jake realizes that's not the case. He looks at his monitors, and they all look good. Next, he looks at the node that the pod was provisioned on, and the node looks fine as well. So Jake looks into this container creating error, and he observes the following scenario. When a pod requests for a container to get created, Kubelet observes this change and communicates with Docker. Docker, in turn, communicates with the CNI to get an IP allocated for this container. However, something was wrong with the CNI where it was being slow or buggy, and it failed to allocate the IP for that container, thus resulting in this pod being stuck in container creating.
Still. Your hair is rubbing.
Oh, sorry. Okay. Sorry if that was an issue.
Stick this down your shirt. I'm sorry. We've got to get a good recording.
Got it. Okay. Hopefully this is better. Sorry, folks. Maybe I should have just put my hair back. Anyways, back to the story. So that is why this pod was stuck in container creating. Jake is able to resolve this issue. However, the next day, another app dev comes with a pod stuck in pending. Then a few days later, another app dev comes in with a pod stuck in terminating. Jake realizes that a lot of these issues that app devs are facing aren't necessarily misconfiguration errors, but something wrong or issues related to nodes. Something's wrong with the nodes. And some of the problems that he is identifying are CNI communication failures, which is the issue that happened with Kim. Other issues such as Docker kubelet restarts or crashes. Disk provisioning failures. High I/O wait times, and container runtime errors. Not just this, but Jake is also observing the following scenario. A bunch of Kubernetes system services appearing healthy, yet their underlying pods are constantly restarting or crashing way too often. Jake understands that Kubernetes is a highly distributed, large platform, and it's also very self-healing. This presents a scenario where a bunch of the smaller components can go bad, yet go bad undetected because on the top level, everything appears healthy and good. Jake wonders if he can actually catch some of these issues that app devs are running into with their pods and services. So Jake comes up with an idea. He thinks, why not run synthetic tests against core Kubernetes cluster functionalities to ensure that Kubernetes is behaving as expected? And so instead of having app devs run into these issues and problems, why not catch these issues before app devs run into them? So if you guys know this meme, it's a very famous one with Odell Beckham Jr.'s famous impossible catch. And basically, kube operators want to be like him, catch things before app devs run into them. So Jake comes up with a bunch of synthetic tests he believes would test core cluster functionalities, such as the Daemonset Check. A Daemonset Check essentially ensures that all pods can be provisioned on all nodes in the cluster. Not only does this test whether or not pods can be provisioned on all nodes in the cluster, but it also indirectly checks for node health, making sure that nodes can actually get pods provisioned onto them. He also comes up with a deployment check, which is actually really important because this replicates a real dev user's experience using Kubernetes, because it ensures that a deployment and service can be created, provisioned, and serve traffic in a Kubernetes cluster. A DNS status check to make sure that there are no failures with DNS, resolving endpoints within and outside of the cluster. So along with these checks, he comes up with a bunch of checks that he believes would test core cluster Kubernetes functionalities. And with these checks, he wonders how he can get notified of when some of these things fail. So in order to get notified of this, he decides to create a JSON status page. And this JSON status page has a list of all of the checks that he's running, as well as whether or not the check passed or failed. And if the check failed, a list of errors associated with that failure. Not only does he include this JSON status page, but he also includes an InfluxDB as well as a Prometheus integration, so that this check failed or passed information essentially turn into metrics themselves that can be monitored. And with all of this, Kuberhealthy is born. So that's how the Kuberhealthy project came about. And like Sheila said, this project was open source back in 2018. So Kuberhealthy came out, and now Jake gets to be that cool kube operator that catches things before his app devs run into them, and app devs are now all happy. Some time passes, and other kube operators learn about the Kuberhealthy project and wonder, can they add more synthetic tests? I mean, there are other synthetic tests that can be run against a Kubernetes cluster. However, with the way Kuberhealthy was built, it was hard for other than code maintainers to actually get involved and add checks themselves. Not just that, but app devs learned about Kuberhealthy and wondered, since Kuberhealthy runs a bunch of synthetic tests and checks in Kubernetes, can they also potentially act as synthetic monitors for their apps and services in Kubernetes? With these suggestions, Kuberhealthy 2.0 was born. And the whole goal of Kuberhealthy 2.0 was to make checks extensible. So make Kuberhealthy extensible, meaning that we want to give kube operators and app devs the ability to create, remove, and add checks however they wanted to. So in order to achieve this, what we first had to do was remove checks embedded into Kuberhealthy and essentially create the ability to add external checks. The way we achieved this was by using custom resources and creating the Kuberhealthy check custom resource. So instead of having checks embedded into the code base, we now abstract them out by using these custom resources. Because now Kuberhealthy check resource contains all information about your check. Not only does it contain all of your check information, but it also contains your check program itself. Because your check program, all it is a container. So with this abstraction, you're able to create and add more checks however you want. And now Kuberhealthy acts as an operator, provisioning, managing these checks for you. So let's take a deep dive into what this Kuberhealthy check configuration looks like. So you see our standard configuration, and for this in particular, we're looking at the deployment check Kuberhealthy resource config file. It has your standard resource, which is a Kuberhealthy check. It contains your metadata information, including your check name, and as I said before, we're looking at the deployment check. It also specifies which namespace you want to deploy your check into. Then it contains your normal specs, which is the run interval. That determines how often you want this check to be run. You also have a timeout specification as to how long this check should run before it times out. You have the ability to add extra annotations and extra labels. And lastly, we have our pod spec, which essentially looks like any other pod spec you'd find in a Kubernetes resource. It has all your information on the container that's being run, as well as your image of your check program. And this pod spec essentially is what's being provisioned by Kuberhealthy. And there you have your KH check configuration. So when this KH check configuration is applied to your cluster, Kuberhealthy recognizes this resource automatically and creates and provisions a checker pod. This check pod runs your pod spec and runs that program for your check. And so when this check runs, it has to also communicate back to Kuberhealthy whether or not the check passed or failed. And the way this happens is when this checker pod is provisioned by Kuberhealthy, Kuberhealthy automatically injects this KH reporting URL. And for us, it looks like this. So all you have to do in your program itself is read in this KH reporting URL environment variable, make a post request to it in your check program with the following JSON body of OK bool of whether or not your check passed or failed, and if your check failed, a list of associated errors with that failure. For those who like to write their programs in Go, we actually created a check client program for you, or package.
Just talk.
A check client package for you that you can import into your program. And all you have to do is run your check and make one of two API calls. If your check failed, you report failure. And if your check passed, you report success. So with the report failure, I forgot to mention is you have your list of errors that you can also put with that. PSA, we are looking for more client libraries in different languages, just like how we had for the Go package. And if anyone would like to contribute that, that'd be great. So now I'm going to go to the demo section of this talk. And what I'm going to illustrate is the deployment check. Like I mentioned before, the deployment check ensures that deployments and services can be created, provisioned, and serve traffic within a Kubernetes cluster. So with that, we should observe the following scenario. When this KH check is applied, Kuberhealthy will automatically recognize this KH check resource and provision that checker pod to run the check. Like I said before, this deployment check creates a deployment, and in our spec, in our configuration, if you didn't notice, we set the replica set to 4, so we should see 4 deployment pods come up, and we should also see a service get created. So once the service is created and ready, we're going to serve it traffic, and it's going to respond back to us with a 200 OK response. Once we get that 200 OK response, the checker pod should automatically begin cleanup, basically cleaning up the service and the deployment pods that were all created. Once that cleanup is confirmed, the check officially passes. The successful check status gets sent to Kuberhealthy, and the status then gets reported back to our JSON status page. So I'm going to run the demo now, and hopefully it works. All right. Sorry. Actually, Okay, there we go. I cannot see that screen, but I believe, am I applying, did I write kube control? Nice. You guys will have to guide me on this. So kube control -f, where, am I on the demo folder? No, I'm not? Yes. So I have 2 terminals open. Did I write kube control on the demo one? Okay, got it. So I'm not doing that. Gonna delete. Sorry, you guys are my eyes. I'm actually gonna open K9s. Did K9s open? Nice. So you'll see 2 Kuberhealthy pods running. And I'm gonna try to switch over to the other terminal. Am I on the other terminal? Nope. Keep going. Got it? Great. All right. Now I'm going to apply. Thank you. Oh, demos. Does that have the deployment demo full, .yaml? Backspace? Okay, let's see what's... I'm going to just clear everything. Apply -f. No? Okay, all right. Is it still on demo? Okay, thank you. Kube control, apply -f. Yes, all right. That is our deployment configuration that I showed you earlier. Now I'm going to finally apply that. So you should see a bunch of resources created to run this check. So with this check, it takes a little bit of time to come up, but what we should see is the checker deployment pod come up first. Once that comes up, we should see 4 deployment pods for that replica set, which we specified, also come up. So we'll wait for that checker pod to first come up from this check, and hopefully this demo works. So we'll just wait for that. It takes a little bit of time. Deployment pod came up, and soon we should see 4 deployment pods also come up as well. So we see it coming up, and once it's running, it should be ready to accept traffic. And once it accepts the traffic, it should do its cleanup and be also in terminating status. So it's coming up, it's running, it's ready, it accepts traffic. Then it goes into terminating, cleaning up mode. And once it's finished terminating, our deployment pod should be completed, or our deployment check should be completed. And there we have it. So that is a demo of the deployment check. Back to my slides. So yes, that was our demo. Thank you. And thank you so much for being my eyes as I couldn't see the screen. But as you can see here on this page, not only do we have the deployment check configuration, but we also have a bunch of other checks that our team has come up with. So as long as you have Kuberhealthy 2.0 installed in your Kubernetes clusters, you can apply these checks and get them also running in your clusters. To learn more about our project, make sure you check out our GitHub page, Comcast/Kuberhealthy. Comcast/ also contains a lot of other open source projects from Comcast. And also, we have a Slack page, a Slack channel within the Kubernetes organization, so please check that out as well. Lastly, so these are some of the main contributors or core contributors and maintainers of this Kuberhealthy open source project. As you can see, they're all kube operators, and they're all here today, so make sure to meet with them, ask some questions. And lastly, we also have stickers, Kuberhealthy stickers, if you guys are interested. So with this talk, I'm really hoping that I was able to accomplish the 2 things that I set out earlier, which is 1, to inform you guys more about what Kuberhealthy is as a project and more of the work that we've been doing in the past few months. And 2nd, hopefully incentivize you guys to implement Kuberhealthy in your own Kubernetes clusters or contribute to the project. Thank you. We'll just be up in front. Yeah.
So we're done for the session. We have stickers here. and catch Sheila and Josh for question and answers outside the hall. Thank you.